Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. Which statement about the following reaction is true? I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now if you look at, this is the reaction of potassium tertiary butoxide with water to produce tertiary butanol and KOH. And in this context, four options are provided. Which one is actually true? By the way, before going to the answer directly, I suggest you to have a better understanding about the basic concept, and let's answer few questions. Now if you look at here, this is a tertiary butoxide. By the way, first question, who is stronger acid? Now acidity is decided by looking at the pKa value. Lower the pKa value, higher the acidity. So I can say here water is actually the stronger acid compared to this alcohol. So this alcohol is weaker acid. Similarly, if you look at this base, this tertiary butoxide is actually stronger base. Why? Because the oxygen center is more electron rich. Why it is more electron rich than this hydroxyl? Because look at here, there is a hydrogen, so no plus I, no plus R, nothing. But if you look at this, a tertiary butyl group, and it donates electron density through plus I effect. Consequently, this oxygen becomes even more electron rich. So obviously it's stronger base. So if you look at from stronger base plus stronger acid, what I'm getting? Weaker acid, and obviously this is also a weaker base. Now, if you think this much, so what will your understanding? Sir, stronger base, stronger acid, I'm getting weaker base, weaker acid. So equilibrium is expected to prefer this product. So equilibrium will prefer the product side. By the way, this is your answer, but I'll answer something more. Now, which product will predominate in the equilibrium? Obviously, this tertiary butanol and KOH will predominate. Next, stability of the anion. If you look at KOH here, it's comparatively more stable than this tertiary butoxide. So tertiary butoxide is less stable because the electron donating effect of this tertiary butyl group. So which statement is true? The equilibrium favors the product. This is the right answer. Okay. By the way, if you do not know the right answer, how would you get the right answer less than 30 seconds in the exam hall? First, look at the chemical reaction. From these values, you can clearly understand, okay, water is stronger acid than this alcohol. Now, look at equilibrium favors product. I am confused. Keep it. Tertiary butoxide is dominant anionic species in the equilibrium. How? This is a stronger acid. This is a weaker acid. So, obviously, this tertiary butanol is expected to be the major species in the equilibrium. Not only that, water is the weaker acid here. So, this is wrong. No, water is a stronger acid. From this value, it is also a wrong option. And tertiary butoxide is stabilized by resonance. It's not possible. By the way, tertiary butoxide is actually not much stable. It is less stable. That's why you can say it's more reactive. Okay. Not only that, as I told that, okay, it's a strong base. So that will also help to get the understanding, okay, this is the equilibrium will prefer in the right side. So tertiary butoxide stabilization is also wrong. So if you look at these three options, these are wrong. So what remains? Only option 1. So these will be your right answer. Is a back calculation strategy. Using this, you can get the right answer very quickly. So in conclusion, what you have learned, that strong acid to weak acid formation is thermodynamically favorable. So the equilibrium follows the thermodynamic pathway, or thermodynamic choice. And here potassium tertiary butoxide is stronger base than potassium hydroxide. And since it's an organic part is there, that's why its solubility is more in organic solvent than obviously KOH. And the very interesting point, if any component of equilibrium is consumed during a chemical reaction, then the equilibrium will try to readjust itself to minimize the effect of that change. This is actually an extension of last atelier principle. Now why? Because the equilibrium constant is fixed at a particular temperature. If you consume any product, so the product concentration or reactant concentration decreases, so the equilibrium constant is expected to change, but that will not happen. In order to keep this equilibrium constant unchanged, so the equilibrium will readjust itself. Okay, so this is the overall discussion. I believe this video may be useful. Thanks for watching. See you in my next video. Bye bye.